Welcome and hello. This is a video exercise using the FHWA hydraulic toolbox. I'm titling this one Field Gradation Measurements because what I've done is gone out into the field, taken some real world measurements, and then going to use the rock/sediment gradation analysis tool or calculator within the hydraulic toolbox to identify the gradation of a sample of soil. Okay, so let's go ahead and get started. Fire up your hydraulic toolbox if you want to follow along. This one is already completed, so I'm going to add a new calculator. I'm going to come down here to the new rock/sediment gradation analysis. I'm going to leave a link in the description to the lesson on this topic, so if you wanted some background information, go ahead and check that out. All right, so it says rock sediment gradation analysis 2. I can rename that if I want, but we'll just leave it at that. We'll double click to open up the calculator. And now what I'm going to do is add two different gradations. The first gradation I'll just add, this is going to be for the manual measurement. So I'm going to first of all rename it to just G1 equals, we'll call it manual measurement. Okay. And then my two different options is riprap count or stream bed pebble count. I'm going to go with riprap count. Oops. There we go. And then define the particle counts. The other gradation I'm going to do is add image gradation, where I take a photo of the actual rock particles or soil particles at the location with something else in view to use as a scale. Like I brought my ruler out to the riverbed and I took some photos with that in view. So we'll see that in action in a little bit. Okay, so here is the add gradation. Next, I'm going to click on the define particle counts. This is where we add a transect. So transect 1 is what it's called. And what I'm going to do is edit the transect, type in the number of points. So this is the number of rock particles that I measure in an unbiased fashion. I'm going to use 20 for this first transect. It's going to be the only transect because out in the field, I realized I was just taking too long trying to hold the camera and everything. But we're going to cut to the field footage in just a moment. So I'll click OK. Oops. Yeah, you don't have to actually click OK. You just got to type in the number and then tab off. But edit transect. Okay, so it has my points. And then what I'm going to do here is type in the actual measured diameter in units of inches here because I'm using US customary. And the process is I'm just going to walk along in the straight line and measure whatever is under, I think, my left big toe. In the video, I say right big toe, but I mean left. Yeah. So enjoy the field measurements. I'm going to cut away from the normal video. You're going to see me out in the field by the river taking some measurements. So enjoy that part. After that, we'll be back here to record the data.
All right, we are out here on site at the river, here to take some measurements for grain size distribution classification in the hydraulic toolbox. And as you can see, I've got the river behind me and a riverbed. Here is the river, and half the time this is underwater, so I think it's a pretty good representation of what would sometimes be underwater. As you can see, this is the type of particles that we're going to be measuring. I'm going to be making my first transit in this direction right here. So what I plan to do is take a few steps and then measure whichever particle, rock particle, is underneath my, we'll say my right big toe in that direction that I'm walking. I've got my clipboard and a tape measure with me. We'll go ahead and see how this goes. Okay, so here's my first rock. If I measure that rock in this direction, I'm going to go with, let's go with 5.1 inches. So for the first one, I'm just going to write 5.1. So for this one, I'll say it is, how about maybe 4.0? I'll probably say this one is also 5 inches. Okay, so this one's a little bit larger. I'd say 6 inches right there.
I just made up the rest of the numbers. You're seeing them on the screen here. So now I'm ready to move on to the next part where I take a photo.
All right, I'm now ready to take a photo of the sediment that I've been measuring. And what we're going to do is, I've got a few notes here. I'm supposed to be aiming the camera straight at the rock particles. It's supposed to be a high resolution photo. Remove any debris from the area if there is. The light should be soft, not like glaring in the sun. And then finally, I should include an object for scale. So I brought a yellow ruler that I'm also going to add just to the very edge of the photo for my scale. Okay, let's go ahead and find a spot where I want to actually, maybe like right over here. This is about where I was walking.
All right, and here are some of the photos I took. All right, we're back in the office now. We've collected the data. I have my clipboard with the numbers right here. Full disclosure, I only made 5 measurements and I just typed in the remaining 15 for a total of 20 because it just wasn't very fun. But in reality, I would have done it correctly. So I've got my numbers saved right here in Excel. I'm just going to go ahead and copy them to my clipboard, select the first value, Control V, paste, all right? So here are my 20 values that I measured. 5 of them I actually measured, the rest I just synthesized. And then I'll go ahead and click OK. So that was the first transect. I can add additional transects. Click on that transect, click Edit, type the number of points. I'm not going to do that though. So this is most likely not a large enough sample size to be representative. But, this is just an exercise to demonstrate how the software works and also the procedure as well. So I'm going to go ahead and click Delete Transect for Transect 2, stick with my Transect 1, and then plot the results. Okay, so this looks a little artificial. This is our semi-log grain size distribution, percent finer on the vertical axis, and then the grain size in millimeters on the horizontal axis. This will look a little better once we have a few more gradations added to the plot. The table of data shown here shows the number of particles for each of the sizes. So the percent finer, the number of particles of my 20 was smaller than this 3 inches or 76.2 millimeters was 6. And then the number out of that batch of 20 between 76.2 and 107.95 millimeters was 5 for a total of 11. And then this is the cumulative count in this column. This is the individual count in this column. It looks like the largest size was between 152 and 215 millimeters. And then I had 4 recorded rock particles in that size range. 20 was the total. That's 100%. So that's cool. I'm going to click OK. And then that is G1 manual measurement. The other thing I'm going to do is add the image gradation. So instead of add gradation, where I do the manual measurement, click on add image gradation, and then click on that one so we can rename it and define the image. So I'm just going to call this G1 image. Yeah, just image is fine. I called it G1 because it's a photo of the same location. I could call it location 1 and location 1, but gradation 1 and gradation 1 is also just meant to be the same location. If I had a different location, I may change the name. But that's good for now. I'll click on Define Image Gradation, and there's lots of bells and whistles and features to this interface that I could explore, but I want to sort of keep things simple for this exercise. I only took about 3 or 4 photos, but I'm only going to use one. So I'm going to click on 1 right here for number of photos. That's already set. And then click on browse to that photo. Here are the photos right here. So eeny, meeny, miny, mo. Let's go with this one. Pick number 2. And then clicking on setup allows us to modify some of the properties of the photo prior to the actual analysis. So you can see we have some larger rock particles, some smaller rock particles. Right here across the top is the ruler. So this right here is 12 inches, or maybe a little bit more than 12 inches. So one of the things I need to make sure to do here is set the scale so that this image processing tool can go around, trace the rocks that it can see, and then base that diameter on this 1 foot dimension length. This is the standard scale length I'm using for this photo. All right, so to do that, we can just click on Set Scale. Here are the different tools over here. I'm going to click on, Set Scale. And then it's kind of hard to see, but the 2 little scale marker icons are here. Oops. So click here, and then I think I click here. No, I click there. Okay, there we go. Takes a little bit getting used to. The first click is going to actually place the first marker, and then you just do a single left click at the second location. That will place the marker somewhere else. Down here, I need to set the value, so I'm going to set that to 12 inches. And there's other options for cropping and filtering, threshold, regions, polygons. But what I'm going to do is just click on results, skip to the results, and it looks like it's performing an operation right now. So it went through and did all the counts. And what you're seeing in this table here is a summary of the number of particle counts, the cumulative, the percent finer or percent passing. So this is the exact same table at except there's different data, there's more data, and the particle size count looks like it's much smaller. At least, let me scroll down a little bit. Okay, so the bulk of the particle sizes was in this range from about 57 millimeters up to 228 millimeters. I'm curious how that compares to my manual measurements. So I'm going to click OK. Now, I don't know if you can see it, but the image is modified a little bit. You can see these thin red lines that sort of outline the particles that it identified. And it identified a ton of particles, probably hundreds of particles in different sizes. So that's a lot easier and faster than me physically walking around and taking measurements and trying to record it with my phone. Okay, so that's good. I'm going to click OK. And then what I have is my summary data right here. If I wanted to add another photo, I could do that, but I think I'm good. So I'll click OK again. Here is the grain size distribution from that image: D5, D15, D50, D85, and D100. I believe the same distribution is available for the manual measurement. Okay. It is, but for some reason, the D5 and D15 kind of got goofed up. I think it's just simply because I don't have enough numbers. I only had 20 points, and it probably needs a little bit more variation than what my manual measurement data provided. But that's fine. Let's go ahead and click on the plot all gradation curves right now. And we can see that we are pretty close. It looks like the blue line right here is the G1 manual measurement. That was the first data that we put in. And then the magenta colored data set, this line here is the data, the gradation that was determined from the photography and the photo scanning feature. So it looks pretty close, at least for the upper end. I think the blue data, the manual measurement, is a little bit larger because I was just biased towards measuring a little bit larger size rock where I put my foot. I wanted to pick the largest rock, not the smallest rock to measure. So maybe that's one explanation. So what I want to do before the end of this exercise is to add the standard riprap class sizes to see how these two compare. I'm guessing these are a little bit on the small end because it didn't look like riprap. It was a little bit smaller than riprap. But to do that, click on this Add Standard Riprap Gradation. Okay, so it says riprap 3. That's the name of it. I'm going to use class 1, which is the default here. So class 1. But I'm going to rename this to just riprap and then class 1. Okay, so that's cool. And then let's plot all gradation curves, which will include that riprap class. And then here we go. The riprap class 1 is in red, and sure enough, it's a little bit larger than the measurement of the rock particles I measured manually in blue, and of course larger than the ones that were determined via the photo processing routine in magenta. So if I added riprap class 2, it's going to be even larger, and it's going to be to the right of this red riprap class 1. So there's really no need to add any other riprap classes. Clearly what I was dealing with here was a little bit smaller than riprap class 1, but that's fine. So that's it for this exercise. It was a little field work. We took some measurements of different rock particles in what was supposed to be an unbiased fashion near the river. And we used two different methods to categorize those gradations. There was the manual method, G1 manual measurement using riprap count as our type. And then secondly, we use the image processor to take a photo, upload the photo, and then set the scale, and then let the software do the work to identify our gradation. Lastly, we compared that with an existing riprap class and got the results for our gradations.